We are asked if x is divisible by 30, is 6 a factor of x? So this is an example of a factoring unknowns question because we're given an unknown, x. We're given one of its factors, so 30 is a factor of x if x is divisible by 30. And we're asked to find whether 6 is also a factor of x. So keep in mind that for these questions, you'll see these keywords often: multiple of, factor of, divisible by, with some variables. These are more or less interchangeable, as you'll see in a second. So we're told that x is divisible by 30 and asked if 6 is a factor of x. Another way to think about this is to say, well, x is a multiple of 30 if it's divisible by 30. And so we can do this question by picking some numbers and saying, well, maybe x could be 30, for example, or 60, or 90, or 120. These are the first four multiples of 30, in fact. And then asking ourselves, is 6 a factor of all of these numbers? Or does 6 divide into these numbers? Are they divisible by 6? So 30, for example, is that divisible by 6? Yeah, that's 5, so that works out. Is 60 divisible by 6? That's 10, so 60 is, 6 is a factor of 60 as well. Is 90 divisible by 6? We can divide this by 3, we get 30 divided by 2, and that gives us 15, so 90 is also divisible by 6, or 6 is a factor of 90. And 120, is that divisible by 6? Yeah, that's 20, so that's true as well. So for the first four multiples of 30, 6 is a factor of them. And we can safely assume that, yeah, if x is divisible by 30, if it's a multiple of 30, 6 is also a factor of x. But we haven't actually proven it. What we've done is we've picked some numbers, and we're pretty sure that for whatever other multiple of 30 we pick, 6 is also going to be a factor. But how can we prove that 6 will always be a factor of any multiple of 30? Well, the thing to recognize here is that, here, let me actually erase this. When you have multiples of 30, what you have is 30 multiplied by something. So here we have 30 times 1. 60 is 30 multiplied by 2. 90 is 30 multiplied by 3. 120 is 30 multiplied by 4, and so on. So if a number is divisible by 30 or a multiple of 30, it's 30 times something. So x is actually 30 times some unknown. And if it's 30 times some unknown, what we can do is we can prime factor 30, and we write this as 2 times 15, or 3 times 5. And so we now have some of the prime factors of x. If x is 30 times some number, that means that x is equal to 2 times 3 times 5 times some number. And this should remind you of the previous video, because now that we have a partial prime factorization of x, remember, it's an unknown. We don't know all of its factors. We do know one of the factors. We've prime factored that, so we now know some of the primes of x. We ask ourselves, is 6 a factor of x? And 6, its prime factorization is 2 times 3. What we're really asking is, from the prime factors I know of x, can I make 6? From the components of x that I do have for certain, can I make a 6? And yeah, 2 times 3 gives me 6. I see, or another way to ask it is, are the prime factors of 6 present in x? And they are. So we've now, without having to pick numbers, we've proven that 6 is a factor of x, because the prime factors of 6 are found in the prime factors of x, those that we know. So let's use the same strategy for question number 2. Let me just erase this to get a little bit of space. And let's take a look at this next one. So if x over 20 is an integer, is x over 8 also an integer? When they say x over 20 is an integer, that just means that x is divisible by 20, which again means the same thing. 20 is a factor of x, or x is a multiple of 20. So we can write that as, well, x is equal to 20 times some number. If it's divisible by 20, if it's a multiple of 20, it's 20 times something. And if we prime factor 20, this is 2 times 10, this is 2 times 5. So now we know that x is equal to 2 times 2 times 5 times some unknown. The question is 8 also an integer? So 8, I'll prime factor here, is 2 times 4, which is 2 times 2. So 8 is equal to 2 times 2 times 2. And now, can I make 8 from the prime factors of x? Do I have, in other words, all of the prime factors of 8 in the known prime factors of x? I have a 2 and another 2, but this third 2 is not present up here that I know of. Now, it could be inside the question mark because we don't know what we're multiplying 2 times 2 times 5 by. But we don't know for certain whether there's a 2 in there. And so we can't answer this question with a yes or no. We have to say not necessarily. Maybe, maybe not. If there is another 2 that we find in this question mark, yeah, we can make 8. But if we don't find a 2 down there, we can't make 8. Let's try question number 3. Let me just erase this. All right. So if the positive integer a is a multiple of 9, so I'm going to write that as a is equal to 9 times something, so it's 9 times something. It's a multiple of 9. And the positive integer b is a multiple of 12, so b is equal to, I'll do the 12 in blue, why not? It's 12 times something. Then a times b, that's what ab is, must be a multiple of which of the following. So ab, by the way, let me prime factor them first actually. So 9 is 3 times 3, so that means we can write a as 3 times some unknown, and 12 is going to be 2 times 6, which is 2 times 3, so b, let's go over here, b is equal to 2 times 2 times 3, so 2 times some unknown. So a times b, or ab, a times b, well, it's going to have the 3 and the 3 from the a, and it's going to have the 2 times 3 from the b, and then it's going to have 2 unknowns. So what we know about a times b is that there are 1, 2, 3 3s and 2 2s. Let's take a look at the questions. If I know that ab, its partial prime factorization is this, that these are some of the primes that we know for certain, or rather these are the primes that we know for certain are in the product of ab, is this thing a multiple of 24, 27, or 36? And the easiest way to do it is to prime factor these. So 24, when you prime factor, is actually 2 times 2 times 2 times 3. So 2 times 2 times 2 is 8, times 3 is 24. The prime factorization of 24 is 2 times 2 times 2 times 2 times 2 times 3. Is this a factor of this thing? In other words, can we take these known primes and make 24? Well, we've got 2 2s and a 3, so we can accommodate that, but we're missing one of the 2s. Now that 2 again could be in here somewhere, but we're not certain of that. So 24 is not necessarily, it doesn't have to be a factor of a times b. Now 27, I'll just erase these over here. 27 is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Well, here's the 3, here's the 3, here's another 3. 27 is a factor of AB because all of its primes occur over here. Or we can make 27 out of the primes of AB. And let's erase that over here. And finally, what about 36? 36 is 2 times 2 times 3 times 3. Obviously, doing these questions is very helpful to know how to prime factor numbers quickly. So that's something that's worth practicing. But 2 times 2 is 4, 3 times 3 is 9, 4 times 9 is 36, so this is the prime factorization of 36. Well, we've got 2 2s, we got 3 3s, so we know for a fact that 36 is a factor of this. And so 2 and 3 are definitely factors of AB, and 24, or Roman number 1, is not.